Hello, everyone. My name is Kyle Demes. I'm the Chief Operating Officer of Our Research, and I was supposed to come talk to you today about Open Alex at the Japan Open Science Symposium, or Summit rather. And I'm really sorry that the timing wasn't able to work and I wasn't able to be there in person. So I'm sending you this recording, and I'm also sorry that I'm not able to be there for a question and answer, but I have left my email at the end of this presentation. And if you do have questions, I encourage you to please reach out to my email. I'm happy to have conversations that way. And again, apologies I wasn't able to do that in person. So the title of my talk today is Open Alex, an open catalyst for innovation in research. And I'm not going to talk broadly about Open Alex. I'm going to talk about Open Alex through this lens of innovation in research and how Open Alex is a solution for problems that have existed for now a couple hundred years. For those of you who haven't heard of Our Research before, we are a nonprofit in the US that specializes in advancing open science through technological solutions. Unpaywall is one of our very famous products. Unsub is another one, but Open Alex is the latest and greatest and the most ambitious project that we've done to date. At a glance, this is what I'm going to talk about in this presentation. Open Alex defining the problem that we've had for a couple hundred years and talking about how Open Alex is a solution for that problem. But then I want to spend quite a bit of the time talking about specific innovations that have been enabled by Open Alex to give you a sense of what I mean by we're trying to catalyze more innovation. And again, there was supposed to be a question and answer, but I've left my email instead of that, and hopefully you'll reach out with your questions. Okay, Open Alex, a big solution for a big problem. The problem here is that science advances knowledge, but often very slowly and in silos. What I mean by that is you can see on this very simple diagram, we have an institution or a university in hundreds of countries around the world, and you can see a researcher in one department, in one school, in one faculty, at one university is writing publications and advancing knowledge in their field. But because they might publish in different journals, and those journals are different publishers, there isn't actually any way of making sure that the knowledge this person is creating is advancing other fields as well. And we've done this intentionally in science. There's a lot of information out there. There's around 10 million new publications every year. It's too much information for any researcher alone to deal with. And so we've created these sort of these disciplinary journals, these disciplinary departments to organize this flow of information. And that's really convenient. I'm a marine biologist, and I spend a lot of time with marine biologists, and we help advance knowledge in our field. But if someone is creating an advancement in knowledge outside of our field that is relevant, we might not ever learn about it. And that's what I mean here when I say progress is incremental. And these silos that we have are what are keeping that information from flowing. And I want to give you one really important example that I think about a lot. This paper is from 1986 from Swanson on fish oil Raynaud's syndrome and undiscovered public knowledge. If you haven't read this paper, the DOI is down there. I recommend taking a look at it. But it spells out this problem of how silos are slowing innovation. And specifically in this example, there are two silos. In the first one, a bunch of researchers in medicine have discovered that Raynaud's syndrome is associated with high blood viscosity. There are some other characteristics of this syndrome as well, but this is one that they are focusing on. A second silo of researchers who have never cited each other's papers, who probably have never even read one another's papers, discovered that fish oil as a supplement can decrease your blood viscosity. And the argument that this author makes is that if these two silos didn't exist, we would already know that fish oil can help treat Raynaud's syndrome. But because these are in completely different silos, they don't cite each other's paper, there's no flow of information, that treatment was never discovered until this person wrote this paper. This paper outlines why this is a problem and proposes paths forward to help create some new innovation. I will point out that it is now it's almost 40 years old, And a lot of the problems still persist. And I think that's an interesting thing to think about, which is why I come back to this paper all of the time to try and figure out how can OpenAlex finally provide some of the solutions that this researcher pointed out. I should also mention that the paper is behind a paywall, and that might be one of the reasons that more people haven't learned from this publication. Okay, so OpenAlex solves this problem and many more by connecting all research information in one place openly. What I mean by that is we have information on publications. This is one example. This is one of my papers you can see here, and we understand what the title is, what year it was published in, what journal published it, who the authors were, what affiliations or institutions those authors were at, what concepts the paper is about, what papers were cited by this work, and what papers are citing this work, what papers are related and are working on similar concepts, even if they don't know each other. An abstract, who funded the work. So you see, what we're trying to do here at OpenAlex is take these publications, and right now we have 266 million, and we're trying to connect them to all of these pieces of puzzles, these puzzle pieces throughout the research ecosystem, what journals they are, the known publishers, the known institutions, to make some of these connections. And importantly, it's a really big database and it is completely open. And I'm going to talk about that for a moment. It is currently the largest database by design. OpenAlex as a name takes inspiration from the Library of Alexandria, which was meant to have all of the world's research. So we spend a lot of time thinking, how can we get more and more types of research? There's a few papers that have come out in the last year that compare OpenAlex to other databases that you might be familiar with, like Web of Science and Scopus. Just for simplicity, I have two here. You can see on the left a Venn diagram showing Scopus and Web of Science are very similar, and OpenAlex has quite a bit more publications that aren't in Scopus and Web of Science. Our goal is to not be bigger than Scopus and Web of Science. Our goal is to have all of the world's research. So we're going to continue growing even larger than we already are. But interestingly, on the right, you can see a couple of things here. This graph shows this bar on the left, all of the journals that are open access that are only in OpenAlex. They're not found in Scopus or Web of Science. And you'll see there's 25,000 of these. Whereas over on the right, the publications that are just in Scopus or Web of Science that are open access is very small. The graph below that is another way of looking at these publications and thinking about bias. So you can see the two on the left, Scopus and Web of Science, have a really high bias. So it's above this dotted line, meaning it's a high bias for high-income countries and a bias against low-income countries. At OpenAlex, we're much closer to that lack of bias. We still have some bias, but what we're trying to do is have and be inclusive of all research. So that's really important. If we want to understand connections between researchers, if we want to help find the next cancer drug and things like that, we need to be able to have all research, not just some. So that's important. But the other really important piece that's innovative about OpenAlex, and that's really what's allowing so much more innovation on top of OpenAlex, is that it's completely open. We have three ways of accessing the database. On the left, and this is completely unique, no other database allows this, anyone in the world right now can go and download the entire snapshot of OpenAlex, try and make really big studies and really deep understanding of the research ecosystem. That's something that has been limiting innovation in all these other databases, is that you can only access small amounts of data at a time, whereas OpenAlex, you can get all of the data. The next way you can access it is through an API, which is also open and very well structured, and that allows people to build tools on top of OpenAlex. So this is really important for a lot of new tools that people are building. They're using either the snapshot or the API, which are both open. And then the third way of accessing it is with a user interface. This is a lot more limited, but it does allow people who don't have technical capacity to start exploring the database. But regardless of how you access the data, whether you're doing the full database, the API, or the user interface, all of our data are completely open under a CC0 license. That means that you can use it however you would like, including commercially. And this is really exciting for me. We want to spark all sorts of new innovations, but we don't always know what people are doing. So I went to a conference in Charleston last November, and I met 9 new companies that built their company and their innovation off OpenAlex data that we had never heard of. And that, for us, is a success story that people are building these really great and already successful tools off of this data. But there's some really neat features about it being open that I want to highlight quickly. The first is, yes, the data is open, but also our algorithms are open. So when we try and figure out what this author text belongs to, which person, that algorithm is open. When we say, it sounds like this paper is about SDG 5, that classifier is open. And the reason that's important is because you can deploy our algorithms on your own database. So if you wanted to expand beyond something that we don't have, like patents, for instance, or course syllabi, we hear a lot, you're able to do that. And just as an example here, you can see I went to this is Chris Harley, my PhD supervisor. I copy and pasted how he describes himself on his website into our text classifier for the Sustainable Development Goals, or the SDGs. And you'll see we get a response that he works on life below water and climate action. And I'd say that's exactly what he works on, sort of the impacts of climate change on marine ecosystems. You can use these exact same algorithms on anything you want. And that's something that you can't do with the other databases. So people are starting to do some really cool connections to figure out not just what research you're doing at your universities, but what courses you're teaching and where's the mismatch. Maybe you have publications on an SDG, but you don't have a class that teaches that SDG. You can only start asking these questions because the algorithm is completely open. It also, because we've made these algorithms open, it also deepens connections to other systems. And I want to give you an example. NSERC is a national funder in Canada. It's like the NSF for Canada. And right now, they're not in a lot of these databases. So you can't sort of do analyses, but people do want to know, what is NSERC funding? What is the impact of NSERC's funding? So as an example, we showed you can take from the NSERC database, run that information in OpenAlex using our classifiers to figure out, okay, for all of these grants, what is the topic that they're publishing on? And then can you find that in OpenAlex? So this is just an example where we took one grant. Again, this was my PhD supervisor, Chris Harley, ran it through our classifier and found the impact of ocean acidification on marine ecosystems. I then looked at that topic in OpenAlex to see who's working on that topic and limited the country to Canada. And I found, well, among other people, my PhD supervisor. So this proves in concept that you can find experts on particular things that aren't in OpenAlex yet. So if you have a mission statement for a university or a mission statement for a company, you can classify that text in OpenAlex and find all the researchers in the world who work on it and the institutions you might want to collaborate with. All of that is possible only because these algorithms are open. Okay, now I want to spend a bit of time going through specific examples of what I mean by these innovations that are enabled by OpenAlex. A very important one for researchers are discovery services. I mentioned that there's sometimes around 10 million publications, depending upon how you define a publication each year, and researchers can no longer keep up with that. It's too much. So there are specific services. There's 3 examples here: DeliverX, globalcampus.ai, and Scholarcy, which help researchers find the relevant research faster to help make sure that that part of research goes more quickly and that they're finding all of the relevant work. So when I mentioned that Raynaud's syndrome problem a few slides ago, this could have helped those researchers who are working on Raynaud's syndrome by saying, we think that these are some publications that might help treat Raynaud's syndrome because they have the symptoms in those papers. So this is a very important part of innovation in the research ecosystem right now. A lot of these are AI-based, and we're finding sort of LLM, RAG, all sorts of really neat and powerful developments that are helping researchers discover the research they're looking for. I talk about this as helping researchers. This also helps companies because now you can find the experts around the world that work on specific topics. So if you have a problem you're working on in one department of a company, you can put that into OpenAlex or one of these services and find the experts globally or near you. You could also find recent graduates and as part of a talent recruitment program, only because this data exists. So that's one example. Another example I have for researchers is this idea of meta-science. So studying science itself. There's a lot of ways of approaching it, and it used to be very inaccessible with only a few people in the world really understanding how to do these analyses. But because OpenAlex data is open now, and VOS Viewer, which is the most well-known, I guess, meta-science tool in the world, I would say, and very well respected by librarians and researchers, it is also open. So they've built an integration with OpenAlex where anyone can explore openalex.org and our user interface, copy and paste the URL into their program, and it will go ahead and visualize. So in this example, I showed the University of Windsor, and I was looking at all of the institutions that they collaborate with, and then I overlaid how impactful those citations are as a color, just to give you an example of which institutions were these collaborations being very impactful. But all of this can be done by anyone openly now because of these innovations. Okay, another example I want to give is still in the research ecosystem, but is more through the lens of a publisher or a university that is managing that research. So this sort of diagram here, this is coming from Kronos Hub, shows managing the entire research lifecycle from pre-submission to help find reviewers, to work with eligibility checks and approvals and invoices and reporting, all the way to repositories and full text deposits. So the entire life cycle of a research publication. And you can see at the center, they've got OpenAlex and all the different places that that data is fitting in. So OpenAlex can provide the data, but they're providing this tool to help libraries and universities manage their publishing platforms and really understand how these changes in open access are really working. So this is a great example, and I should say I didn't earlier. At the bottom of all these slides, I try to give a link to either more information about this specific example or a webinar. So this was actually a webinar that Kronos Hope gave on how they use OpenAlex, and this is a great example if you want more information on that to go there. The next one I want to talk about, we're seeing more and more all around the world, are these national research portals. And what I mean by that is going to one place on the internet and finding all of the information about the research in that country. Not every country does this, not every country wants to do this, but most countries are thinking about this in some way, shape, or form. I had to give a big shout out to the Danish government. I think the research portal of Denmark is a really great example of how this can work, and they're leaders in this field. But they've created Research Portal Denmark to find all of the publications by Danish researchers and link that to people and funders and Danish organizations and some other priorities. So you can see here they have subjects like the OECD classification. We didn't have that in OpenAlex, but this was really important to them, so we worked with them to create that classification scheme. But now anyone in Denmark or anywhere else in the world can go and really just explore and discover Danish research. We're seeing these more and more around the world, and I put another example down here at the bottom for Colombia, but we're seeing these sort of everywhere we go. So this is a very common use case that we're seeing. Now I'll say a lot of universities and governments have the capacity to build things like this, but not all of them do. And so there's a big push for new organizations and companies that can create tools like this using OpenAlex data. So I'll just say that as another example of innovation that's starting because of OpenAlex. Another example I want to point out is research security. I'm not sure, to be honest, how important this is or how big this is in Japan, but this is becoming one of the prominent conversations that we're having with UK, US, Canadian Australian, New Zealand, and many European country universities and country governments as well, where people and specifically governments are increasingly concerned about the security of their research. And they're starting to push onto universities and then they push onto faculty members specific new workflow to help do due diligence analyses to understand the conflicts of interest or which research might have been funded by a sanctioned government or something like that. These can take a lot of time to do. They're very difficult and at scale of the world can be very cumbersome. But open databases like OpenAlex have all of the information you need. And so we're seeing more and more companies that are starting using OpenAlex data to provide a solution to find research security and due diligence assessments. So I gave 3 examples here at the bottom. Secure Analytics is funded by NSF. Blue Scout is a company in the US as well. Secure Scholar is a Canadian example, but we're seeing more and more of these pop up. As an example for a specific institution, I think this is a really powerful one. EPFL is École Polytechnique Fédérale de Lausanne, and they are doing some really fantastic work in open research metadata, and they're using OpenAlex for a lot of their data. But they're building their own internal business intelligence tools or research intelligence tools designed specifically for what their executive want to do. So they want to define custom research areas directly related to their strategic plan. They're doing that on top of OpenAlex data and having it presented in a nice dashboard. They're benchmarking their performance in those areas against other institutions. And then they're assessing the potential for collaboration. So this specific picture, you can see there's 6 universities and it shows sort of a map of all of the research areas of those universities. If you look at EPFL, it has a very similar fingerprint to ETHZ. You can see these are very similar. So this is maybe not an opportunity for collaboration, but is more of a competitor. Whereas this UNISG, you can see has a very different fingerprint with a lot of activity in the areas that EPFL does not. So this could potentially be a very complementary institution to collaborate with. And again, more information on their specific use case here, but we're also seeing this globally, where institutions around the world have specific use cases that they need. Some of them are able to in-house build their own tools. Many of them are not, and they're looking for organizations and companies to deliver these services for them. Okay, there's just a couple more, I think 2 more, before I close off. One of them is something that we've seen in several places. We've seen this from journals, and we've seen this from funders. We've also seen this in universities, but basically, you have a paper that hasn't been published yet. It's being submitted for the first time. Or maybe this is a grant proposal, or maybe this is a funding pitch. This could be any sort of text that describes research. And the idea is that you want to find all of the researchers who are experts in that, so that maybe they could review it, or maybe they could be collaborators on the project, but you're trying to find researchers among the 100 million or so researchers on the planet since the beginning of time, I guess, that we've been recording in OpenAlex. That's a very difficult problem to do, but not if you have an open database like OpenAlex. Essentially, you can take that text, find all of the publications that are similar, and then find the authors who work on those topics regularly. The next step you can do is look at the network of that author and figure out which authors might be in conflict and remove those from the list. So this is a great example, Reviewerly. There's several other of these examples as well, but essentially they've made a toolkit that automates that process. Find me all the people who could be a reviewer and subtract out the ones who, for instance, have already collaborated. And then one more I wanted to throw out at the end that I personally find very interesting. Governments around the world are trying to understand the influence of research on policy. And that's been a question we haven't been able to answer for a couple 100 years, as long as people have been doing research and trying to inform policy. But now because there's an open database of research and an open database of policies, this organization, Overton, has actually created links between all of these policy documents and what is being cited from OpenAlex. So because OpenAlex had an open map of all of the research in the world, they started with that and they mapped that to policies. And now you can ask questions like, which researchers are influencing policy more? What are the attributes of science that help it get cited in policy? You can ask these things to understand influence in government in a way we hadn't been able to previously. So that was a lot of different examples. There are many more, and soon we're going to be building up on our website even more examples so that people can see all the different ways people are using OpenAlex. But I did want to end quickly with a couple of forward-looking thoughts on OpenAlex. We are going to continue expanding the coverage of publications in OpenAlex. We have about 265 million now. We think 400 million is probably closer to the number we will end at. And then, of course, they'll keep publishing, and that will still increase over time. But we're going to keep adding new sources like JALC, sorry. And we're going to add research grant funding, so you can start doing more analyses on research funding. We're going to add research software. We're going to add all sorts of other research outputs until we have all of the world's research knowledge. That's our goal, and we're going to keep growing until we have achieved it. But not just in terms of size and how open we are, it's also really important to think about OpenAlex, because it's this open database, will very soon be the core of research information that's feeding all of these distributed systems. So if you imagine this really complicated and thriving sort of research ecosystem where journals are sharing information with researchers, they're sharing it with funders, they're sharing it with corporations, OpenAlex is going to be the center of all of that, pushing data in and bringing data from all of these different sources, connecting them. So the more and more people are building products on top of OpenAlex, the more connected the entire ecosystem becomes because it's one shared data source for the first time. So I say that to hopefully encourage some of you to think about adopting open metadata and using OpenAlex, but also to think more about the different things you can build on top of it to achieve your specific goals. And with that, I want to say thank you all again. I'm really sorry I wasn't able to be there in person or on time for this summit. So I'm not there to do questions and answers. My email is kyle@ourresearch.org. Please reach out if you have any questions. I'm really happy to follow up with them, and I'll look forward to hearing from you all. Okay, thank you very much. Take care. Enjoy the rest of the summit.